Okay, so here's a question. We've got A, B, C, D at points on the circumference of a circle, centre O. Okay, so we know that this is a cyclic quadrilateral. Okay, but it says, importantly, we have to prove that the sum of the angle ABC and ADC is 180. So we can't simply say that the opposite angles of the cyclic quadrilateral are 180 degrees. We've got to do something more. So what can we do? So let's use some basic facts that we know. So I'm going to use one of our circle theorems. So I'm going to draw a line from A to O. And then I'm going to draw a line from C to O. Okay, so now I know that I've split the center into two angles. So I know that one, angles around a point total 360 degrees. Okay, that is an absolute definite. Okay, two. I'm using one of my circle theorems from the arrowhead. So we know that the angle at the center is 2 times the angle at the circumference. So we can use one of our circle theorems. So I know that if this angle is x, this angle is half x. And I know if this angle is y, because obviously this isn't 180 degrees, then this angle is half of y. So now the final thing I can say is that I know that x plus y equals 360 degrees because of 1. And I know that a half of x, which is part of our center, plus a half of y must be equal to a half of x plus y, because that's just factorizing. So that's equal to a half of 360 degrees, which we all know is 180 degrees. Okay, and that is proved. Okay, so we can't just say opposite angles, we can't talk about cyclic quadrilaterals. What we need to do is we need to prove that the sum of those two angles is 180 degrees, and we find a new way to prove it using a circle theorem.